Thanks to our lecturer, Madam Yuvadharshini. We are from BMMB Section 1. We would like to present a mini project titled Automatic Drip Chamber Sensor. Okay. Myself, Yuvadharshini Jeyakumaran, metric number B0918103553. My group members, Mahafi IZAAT bin ISMAN, metric number B0918100536. And then one Muhammad SHAHRIL bin 1 month, metric number B0918103883. Okay, I pass the next slide to my group member to present.
Okay, next is the background. The drip chamber is a device used to allow gas such as air to rise out from the fluid so that it is not passed downstream. It's commonly employed in the delivery system of intravenous therapy and act to prevent air embolism. The use of drip chamber also allows an estimate of the rate at which fluid is administered. Second, the drip chamber can be classified into the micro drip about 10 to 20 GTTS per ml and the micro drip about 60 GTTS per ml based on their drop factor. Lastly, for background, our group has chosen automatic drip chamber sensor as our project. In addition, the sensor of drip chamber will help nurse to monitor the patient. Based on our observation, the current design has a little difficulty in determining the accuracy of a liquid for a patient. In addition, the old design will also make it difficult for nurse to provide proper treatment to the patient. So we have decided to make a drip chamber to make the nurse can facilitate the work of nurse in caring for and providing service to patient. This device can also provide data and display the data into the monitor in each patient bed. Okay, next is the problem statement. The drip chamber allows gas to rise out from a fluid so that it is not passed downstream. The same device is set manually by nurse for the patient. The flow rate of the liquid from the drip can be slow or fast depending on the setup by the nurse. The recent device not give patient the full need of liquid or the give patient fluid in excess of the required capacity. Next is objective. Our project objective is to design a device that can help facilitate the work of nurse. We also to meet the need of the patient is given adequately. Lastly, for our group, our project objective is to give the patient the best treatment while in the hospital. Next, I pass to Yuvat for literature review.
Okay, thank you, one. Okay, for the literature review, we have studied 4 researchers for case studies based on drip chamber. First one is remote drip infusion monitoring system employing Bluetooth. This one, the connection sensor applying to the nurse room and also the patient's bedroom. So in the nurse room, the nurse can detect regarding the drip chamber through the Bluetooth. Okay, the next one, design of medical infusion monitor and protection system based on wireless communication technology. This one, using a microprocessor, okay, use that, and also transfer the information wireless through our phone or also to computer. Either one, we can detect it either our phone or either in our laptop or computer. Okay, the next one, a new drip infusion solution monitoring with a free flow detection function. Okay, this one using electrical conductivity by using a PVC pipe covered with the electrode with the drip chamber together, and that flow is producing electrical conductivity. From the infusion, we can detect the infusion solution monitoring. The last one, intravenous dehydration drip relief in pediatrics. Okay, this one applying two IV bags, one at the top, another one at the bottom. Okay, this one is applying to relieve the hydration to the patients. Okay, these are the four studies we are made before we are decided to do our automatic sensor chamber. Next, I pass to Afiza to present methodology part.
Okay, for the methodology, the first thing we do is design and sketching concept. This concept is referring to design of our project that is drip chamber with sensor. This sensor is custom designed for the specific drip chamber and is available with single and multi-point detection. The sensors are designed to meet OEM form, fit, and functional specification for various diameter and depths. For the how the device works. This drip chamber level sensor is designed which delivers superior measurement accuracy and performance in medical application. The innovation provides a level of measurement accuracy crucial in so many medical devices, including hemodialysis machine and other liquid or blood handling application. A level sensor is a device that is designed to monitor, maintain, and measure liquid level. Once the liquid level is detected, the sensor converts the preserved data into an electric signal. It detects the level of liquids and other fluid, solid, granular material, and powder that exhibit in an upper free surface. Okay, this is our final design for our project. This design is focused on the size of sensor, the level of water indicator, and the length of tubing. This selection idea was important that will affect the functional of the drip sensor. So we have decided the best design that we can use in any medical department. This is our first technical drawing that is lead. The that sensor. And lastly is our final design. Okay, for boundary condition. We put the boundary condition on the sensor because the sensor is main functional for this ideal project. We have analyzed a linear relation holds between force and displacement. This is the critical area where stress remains in linear of the used material. It used to hold or maintain the position of drip chamber. Shearing force are directed parallel rather than perpendicular to the material surface on which they act. The force per unit of area is called shear stress. Thus, while water are provided no longer term support of shear stress, normally granite, steel, and rubber do so and are called solid. Material with tightly bound atom or molecule like the crystal form below melting point by most substance or simple compound, or the amorphous structure formed in glass and many polymer substance at sufficient low temperature are usually considered solid. Okay. After that, I will pass to my group member.
Okay, thank you, Afi. Okay, this one results of stress. Okay, this one displacement result. This one deformation. So we have found out three results: stress, displacement, and also deformation. Okay, for stress, the maximum value is this, minimum value is 3.936. For displacement, maximum value 1.445 times 10 to the power of -1. For the minimum value, 1 times 10 to the power of -3. Okay, for deformation, the maximum value 5.549 times 10 to the power of -8. Minimum value is 2.154 times 10 to the power of -3. For all three the drawings, we have found the maximum and also the minimum values. When we look at the drawings, all drawings in a good condition and really safety to use in all aspect. For the high stress, it's exerted on the at the edges of the holder, at the edges in three of the pictures, and for deformation and also stress, the high load exerted, the possibility to crack and also to break down the inside of the edges, for the displacement at the outside of the edges. That's the thing on the results part. Okay, next I pass to one to proceed the next slide.
Okay. Lastly, for our project presentation is conclusion. In a nutshell, we have done this mini project successfully. As we planned earlier, we designed automatic sensor deep chamber to give facilitate the work of nurse and give the best treatment for hospital. Automatic flow control of blood in drip is done with the help of sensing the amount of the level in the bottle. A level sensor is placed outside the bottle. It can be measured with the help of variation in the level. The main components are the programmable IC actuator blood carrying bottle. In this project, we get more knowledge on biomedical application on computer simulation. From this, we get to know the more medical device and hospital equipment and its function too. We get more information of the chamber and its feature. We hope this design will helpful in the hospital use. That's all from our group. Thank you, madam.
Thank you,
Thank
madam.
you also for Yuba and Afiq.